Let's derive some formulas for the distribution factor. Suppose we have a rotating magnetic field that turns within a stationary set of coils. Then, by Faraday's law of electromagnetic induction, an electromotive force will be developed in this direction, in this direction, in this direction, in the direction of the stator coils. Forgive me for drawing only 9 slots, but let's focus on one of the 3 phases. Each induced E.M.F is represented by a voltage phasor. We tip to tail all of this into a phasor diagram, yielding the resultant voltage ER. Then, focus on one of the triangles with an angular displacement beta. Beta is also the pole pitch divided by the slots per pole. The resultant angle is the angular displacement times the number of the triangles, or the slots per pole per phase, M. Now focus on one triangle. Draw a median. Since this is an isosceles triangle, these two sides are equal. So, sin beta over 2 is equal to E over 2 all over x. Thus, E equals 2x sin beta over 2, but we have m number of triangles, so the total E is equal to 2mx sin beta over 2. Equation 1. We will now move on to the resultant triangle. Again, a median is drawn leading us to obtain sin m beta over 2 equals ER over 2 all over x. We cross multiply to give ER equals 2x sin m beta over 2. Equation 2. Together with pitch factor, which we derived in part 1 of this series, distribution factor Kd is another reason why the voltage of the phase winding is reduced. This is the ratio of the E.M.F when the winding is distributed to the E.M.F when the winding is concentrated only in one slot, for example. In short, the E.M.F vector sum over the E.M.F arithmetic sum. After similar terms cancel out, we now have the expression for the fundamental component of the distribution factor. We can further unmask this equation by substituting the pole pitch per slots per pole. Now take note that in practical applications, we will usually deal with 3 phases. To further simplify without the slots per pole, since we know its relationship with M, we'll substitute slots per pole equals 3m. After cancelling out slots per pole, we arrive at Kd equals sin 30 all over m times sin 30 over m. Sin 30 is 1/2. That's it. We now have 3 distribution factor formulas in 3 different useful forms. Thank you for watching, and we'll see you next time.